Alright, so we want to install what I call the DIY DataScience Toolkit, and the first thing on the wiki is to install this bit of infrastructure called PeerLink, which sits as a DaMaHub project. So you have to do git clone a directory, test directory. I've named mine the 15th of October today, so git clone. Before we do that, just to confirm the node, confirm the version, and npm. Right, so we just cd into that, and then you'll see all that, and it's just the classic npm install. So what is installing here? What PeerLink effectively is like a web server, which is allowing me to set up web sockets between the toolkit and the infrastructure. So PeerLink contains 3 bits of software. The main one is this thing called Node SafeFlow, which is this engine at the heart of the Health Oracle protocol. It also has a thing called the library composer. So this is what creates our reference contracts. Think of those as smart contracts in cryptocurrency world. The third part is the network library runs on the HyperCore project. So it runs a daemon for HyperCore, and it also sets up the databases running on HyperCore, and they're called HyperTrees. The HyperCore stuff is a lot of installation, and this is what you can see on the screen right now. Sodium is classic encryption library.
Why HyperCore?
I've had Ethereum in there, I've had MadeSafe in there. Basically, all of them didn't quite work when I needed them. And then I just was bold enough to decide I'd create my own reference contract, smart contracting interface with these modules. And that this was a completely new paradigm. But what I did need was a database that I could sync and replicate peer-to-peer. And I wanted one that was reliable and works. And that's why I took this does work and reliably work peer-to-peer infrastructure. It was just like a decision 18 months ago. I wanted something that would do the job. I could concentrate on the new novel stuff. I've got these 5 databases, these HyperTrees, peer-to-peer key index stores, and they help me replicate all of it, part of it. And I have 5 of these. A generic one for the network, one personal to me, one for the results. There's this thing called the knowledge bundle ledger. So it's these 2 entries of the hash of the results, and then all the evidence that make up those results. That's the new paradigm. All the other parts, I can keep HyperCore, I can plug in MadeSafe, Ocean Protocol, any of the crypto storages could be used. Anybody can plug in any database, even a non-crypto database. Key pairs, here's my heart rate from this minute, that next minute. Here's the air quality this minute. Here's the car part data. It's nothing revolutionary database-wise. I have made all the infrastructure on an HTTPS. Right now, we look in here. These library composer, the node SafeFlow, and then these are the interfaces to HyperCore. I'm running this on HTTPS. It's looking for the certificate and the keys. So you can see I've got the keys. This is on the client side, but they're the same keys. Copy those over. So they're not there, so now I've got the keys. So then it's just a case of npm run start, and there you go. PeerLink 2.3 started. Composer's live, the ledger's live, it's listening on port 988, yes, path exists.
Where the part how you go to the contracts, and where the interaction of the system and contracts and their modules? What is the link between them?
Okay, so let's go in PeerLink, and it's a very simple interface, so index the server, right? But really what this is, messaging hub, if you like, the toolkits, and there's the DataScience one and the library one for creating the reference contracts, are basically firing messages into this API. So you'll see all these messages through the WebSocket. So it's here, messages coming in, and it says hello. It says if it's from SafeFlow, then authenticate the library. Is it authenticating a data store? Is it a network experiment we're setting up? All these messages coming in, and then they're routing them to one of 3 places. The library composer, so that's creating the reference contracts, SafeFlow, process the data, or you want to get data out of the peer-to-peer stores, that's peer store. Best to go through library composer and peer store, and then the ledger store, where you see more routing.
Could you show on the GitHub the same thing you showed just now?
I'm calling in those 3 external libraries. So here's PeerLink and DaMaHub. But if you go in, you'll see this thing called Library Composer. So this is the module, and if you open it up, index here. Index is just an interface. Reference Contract Composer. Then you'll see the different kinds: data type reference, a packaging reference contract, a compute reference contract, a visualize reference contract, or these modules that package up various things in the experiment. And I'm basically just routing them. So this is all just like middleware infrastructure, but you'll see my reference contracts here. So data type.
In the data type, you have a space. What does it mean?
Yeah, so a reference contract, well, has a name. There is only like 6 names, right? So it's very limited. Data types, packaging, compute, visualization, and then the concept of a module. In a smart contract platform, there's no notion. You can call them what you want. You can put it in any structure. And I'm taking constrained, even more limited than the non-Turing complete smart contracting platforms. As I said, I'm going for modularity on maybe 15 kind of modules, different types, and then the way you combine them gives you the complexity rather than have it open-ended to code the complexity that you want. So it's a name. And then concept is like this ontology. So anything to do with what is an ontology? I describe that as human thinking, having reason about the world, whereas space would actually be coordinates. I use the example of water. So we could put the Wikipedia definition for water into concept in the library toolkit and the RDF and stuff. But it's like English language ontology. A space, implementation of water, it would be the 3D molecule structure. And then computational would be an algorithm that uses the space coordinates to do something with the molecule structure and makes it dynamic, basically. The computation makes the space coordinates dynamic. So that's just a pure conceptual choice. There's only 4 types, 4 parts to, but obviously within each type, then there's more complexity. The way I've designed the HTML forms to produce the reference contracts, that is the structure. Imagination doesn't have coordinates, right? So I think that's why I put the default in there as space mind. And all the contract is all that evidence hashed with this library, and then I have to prepare a message back into PeerLink. PeerLink gets it and then routes that message onto HyperCore, and then it will save it in the appropriate library, the data type library, save the hash and the contract. So yeah, think of PeerLink as the major router between all the parts of the system. And even like PeerLink itself compromised on making it stand alone on a secure WebSocket. I had sort of hard integrated it into the toolkit. Go back into PeerLink. Yeah, so PeerLink's kind of simple, right? It's just 3 files and then they route. So it creates the server, creates the WebSocket, the secure WebSocket. And then all this stuff here is just listeners and callbacks and routing logic. Is it coming from the library? Is it coming from Toolkit, DataScience? Does it need to go to HyperCore? Does it need to go to SafeFlow? And obviously it's a bit more complicated because some of the journeys require all 3 of those things to be coordinated. Visualization contracts, a new experiment coming in. Let's go and install the network library. So back in our test directory. So what is the network library? Network library is a Vue.js graphical interface that can be published to the desktop or to the web. To the, like a standalone desktop or to a website. So let's just go in and see what's there. So cd network library. So classic Node.js app. So npm install. Concluded the last time by installing the library. So now we need to get the library to work with PeerLink. So we'll just go and so you'll need 2 terminals open. Go to your PeerLink setup. So now we're in the PeerLink. So npm run start. And you may recall that we had the secure server, the keys. So we're going to be running an Electron version, so I need those keys. Copy network library source. Alright, so go to the terminal for the library, npm run. Right, so the library's up and running.
What is happening in background?
What happened, that's basically a Vue.js compiling from the Vue framework to JavaScript, webby stuff, and then building the Electron application. But when you install PeerLink, you can see it says here, paths existing, right? So the very first time we did it, we should have pointed this out, that by default, if you go to the home folder on your computer, Windows, Mac, you'll see a directory called PeerLink. So you have all these HyperCore databases. So there's the network library database. So you can open it up. That's how it's structured for HyperCore. And then what I've been adding is local SQL files. So you can open that. So when you first install this would all be empty. And while I've got a different test environment here, they're all pointing to the same PeerLink. If these don't exist, the first time you load it up, they create all the directories and all the files. So yeah, so everything runs there. It's a bit like an Ethereum, it's like /Ethereum, /main being a hidden folder. I chose not to hide it because I thought for most people are not technical, it's more easy to find. Here's a network library. Very little design or thought, but I just needed to create these reference contracts that we've been talking about. So here they are here, compute. If I click this, then you can see I've already got them made. So think of these as each individual contracts, and I'm just calling them and presenting on the screen.
James, could you go back to the code and show where the code is referenced to this one? Just if we pick up the development.
So this is part of the DaMaHub. So the network library code. So again, it's a Vue.js front end, basically. If you're not familiar with Vue.js, then you're going to have to do a little bit of homework. Views, so home, and it references network status in the dashboard. You go to your components.
And back to the smart contracts, which you're using for any device. So any device connected to a smart contract, which handles the data.
So you can see this is relevant to wearable data, describing computations, heart rate. But as you said, each one's just the links to the definition on Wikipedia. So I'm just going to go through all these. So these are all reference contracts that need to be made, right? But just to go through them, you've got these compute ones, so observationless, typo. Basically just playing back your data. I've got the packaging. I've got this REST API here, this URL, and it's this branch of it, and this is the columns in the table and how it maps to these data type hashes. So our goal is to demonstrate how to make these, right? Go to visualization, so charts.js, 2D charting library. So we want to make these reference contracts. So you have this new reference contract button top right, and then you get this drop down saying what kind of data type do you want to make. Always select primary yes. I have this notion that, some concepts are derived from other concepts. Okay, so Wikipedia page for parking. So we want to create a data type called parking.
There are many sources how to get parking spaces, so you can retrieve them from OpenStreetMaps. Those are publicly available parking spaces or other spaces which we call amenity, retrievable from OpenStreetMaps. And then we have some other data source. We architects are working with IFC. There also data type as a parking space. It's just a normal space, parking space.
I'm at a more primitive level. I'm basically saying, what are the names that are relevant for the columns in your database? That's the primary goal now, is to describe the columns in your database. And I would use the most appropriate source, right? I'm just using Wikipedia, but you could put any URL in there. And that's where the RDF comes in. This is like the ontology building, and that's why I think you need these relationship. Well, that's why I had like primary data type, what's the relationship linked data? So you whack that in there, the RDF links. So this is what a reference contract looks like in the database. So you can see here, this is the one for particulates. Protocol for the Digpedia is just to take the Wikipedia naming. But you need some measurements. So we're just naming an object. Okay, so we filled that in and we just press save. And so if we close out of the create mode, press the get contracts to refresh a call to the database basically. And somewhere down here, we have parking, and this is its unique hash. That is just a hash of that information in that form. Ideally, I'd like a hash of all the source content words of text on the Wikipedia page or the Digpedia page. So the whole goal of this data type is that the network library, like now that you've authored it, if you were to install your network library, connect signing thing, but if I was to then put your public key in there and then press sync, then I would get whatever you've entered, and vice versa. If I give you my public key for this library, you get all that list of stuff. So you don't have to key in steps, parking, air quality, P2.5, right? And by default, all this is like open. So this is what I call the public network library.
It's the base ingredients that we should all share. And so when you're brand new to the network, then you want to sync with enough people. And of course, this will get quite a big list.
So now we have a parking data record entity. So let's create kind of like a car entity.
Yeah, so you go into create mode. So we just primary data type car Wikipedia. In the source reference contract library composer, you had this concept of space. So there should be a field here called space that would reference a 3D structure of a car. Or if I was describing water here, it would be referencing space dialog. I would not code. Now, if you actually go to Wikipedia for like water, you'll actually get on the page a link to a smile file, which is the 3D coordinates of water, 5 formats you can do it in. So, okay, we save it, close, press get ref contracts to refresh it.
Okay, now we have a data set of car parking and a car. Now we can bring entities together. So we are recording utilization pattern from parking space and utilization pattern of the car. You can match it together on your platform.
Yeah, but it's more primitive than that. We first now need to describe the structure of the layout of the columns in your database. And I call that packaging. Could have called it data store. So we need to create one of these. So again, go to add new reference contract. But this time I want to describe packaging, car park, data set. What was it, burn you said? Here you have to say what type of data store it is. Is it on IPFS? Is it a DAT file? Is it a REST API? Is it SQLite file? Is it GPRS or is it a CSV file? I'm just going to go for REST.
Yeah, like AlgoTecture.io or whatever.
So now you have to say, like, what's the columns of the structure. There's a column called car park, application, and type underscore vehicle. So again, you just have to go to your database or your file and just copy the columns, right? And now I'm saying, well, if everybody did that, how many people have described their vehicle type like that one? It could have been, identity. It's like all these words of meaning the same thing. And all I'm doing now is saying, no, the first column is time, the car park is there, car is there. This is like the source data, but what is actually needed is the path to the device. In this case, think of the device being the car park 1, car park 2, but you need to describe, for example, let's say this car park has got a data feed. It will tell you, whether it's vacant or not, and then the next car park would have a data feed. So you need to describe what the source is. In your case, it sounds like the file's aggregated, so you don't need it. And then you have these things like, categories. I'm going to say like the car park column. We've used some data types up here. So now you'll see car park. Here we go, parking. So you could say in that column. So here's how maybe we could do it. We could have had a data type called multi-car park, flat car park, lift car park. And then you go to outdoor car park. That was column 2. If within your column you've got different numbers, then you need to categorize them, and that's how you do it. Yes, there is some tidying up. So if the car parking column has a code of -1, there's just no data available. It could be 0, it could be 255. But whatever the rules are for a column in terms of missing data, then I'm telling the system that information. So then you just save that, close this one, get the contracts again, go to packaging, and here you have the car parking data set. So this is the unique hash. It's at this URL with this path. And here's the columns, how they're described in the source database and how they're described in the network. There is some tidying up rules and there is some categorization. So I've mentioned that they probably need a path to the devices for some use cases. Also, what I should be building in here is a column saying, do you need authorization token to access this data store? For my own personal ones, but if they're public, obviously you don't need it.
Then we have 2 charts between car and parking spaces, so we can combine them and make some utilization patterns. How we can put renting content.
Yeah, so we've got more infrastructure to do. See this number here, this will become very important to us. We want to do data science is your question, and for that we need to install the toolkit, the graphical data science toolkit. So we have our network library, we've got PeerLink, and so now we need git clone of the libraries, the DIY toolkit. So again, this is a Vue.js website, so just cd into the npm install. So this is a non-trivial bit of user interface. I spent the last 6 months half my time between SafeFlow and this year it's 50-50 because SafeFlow gives you all the information, you've still got to manage it and make it useful. So you can see it's quite a big application. What is installing it? But
There is a data mining engine behind it.
yeah, that's SafeFlow, but that's, back in PeerLink here, that's been installed, done this next part, then we need to go into SafeFlow, because it's the engine that matches the two worlds, right? Mm-hmm. So it's taking the source data from the network library, it understands the library speak, so it can take and manipulate as it free, but also then it needs to prepare what the user interface has asked for, and I've asked for many things, and it needs to aggregate those, bundle them, and then aggregate and then give them back. That would be the next phase, but that's probably a whole video session on itself. So let's just get the toolkit. So it's installed. So again, it's just npm in the right box. npm run electron. Again, if you just want to do it through a web browser, it's just deliberately close down the network library UI. So PeerLink will accept multiple interfaces onto it, but it's not advisable at this stage. It confuses it, basically. If you're using the network library, fresh copy of PeerLink and fresh copy of the network library, do your work, close it down, and then, as I'm off to do, bring it to life. So npm start. Right, so you have the starting interface. Help instructions here, hopefully. I've actually built this in such a way that depending on the page you are, it has the capability to understand which page you're on, basically. You press connect, and you can see that PeerLink is live. I've just done this in the latest version. If the link to PeerLink had got broken, this would be red. Or if I press the disconnect button, it would go red. It would break the link. This next section is saying if you need authorization for any of your REST APIs, you have to do that. And then I've got 2 peers in this account already to exchange public keys. And then here are those 4 data stores, PeerLink, which is these data stores here, right? You can just close this. So you can see I've already joined these network experiments, and the whole list sits down here of the public ones. This is in the public library, and basically we now want to create a new one of these for the public network. So we go up here and click on new. And so this is creating what I call a network experiment module reference contract. And it's made up of these elements here. So again, these module reference contracts, if you like. So I put a question in. Where is the data coming from? Now here we've got the link to the network library. So now we want the hash that we just created. You can understand why I just want that link. You just pop up the network library, query for the packaging contract, double click on it, and it would import the code. I didn't do this, so get contracts, packaging. Right, so that's the data source, but we also need to get the compute that we're going to do on that, and the only compute we want to do is an observation. We have the observation contract, and then we want to visualize it on a chart. So again, we get the reference contract for the chart. Right, so if I go to this document here and so it's asking me for a reference contract, and then I just want to look it up, so it's going to go to the network library, and voila, you just get the same information. Again, all this needs to be presented to compute. So you've got a button here, add another source. So if you had like Geneva or Zook.
Utilization of a parking space and utilization of a car. How to match these two data together.
It's a bit like me doing air quality and wearables. So again, just to complete this thing here, so we've got our compute contract, which is just an observation. So again, if I look it up, it will bring back observation. And then I've got the visualization. So here you get the interface like for settings. So it's timestamp on the x-axis. I want vehicle, that column there, and I want this column here. I don't want any categorization at this time. It's on a daily basis, and the data is coming in per minute. It could say per day and stuff. These are hardwired in right now, but So right now, you're just going to contribute this, what I call a Genesis network experiment template contract to the community. So if I click on that contribute experiment, then if you'll see now in the public library, you have your car parking experiment available. Everybody comes and syncs their library with the network, then they would have this list. Like from your point of view, you have to join it. First create it, second join it. Okay, so preview join. So it looks similar, but this time I'm just saying, where's my data source? There's only one, right? But if I'd created multiple data sources, I'd be saying, do I want car parking in Bern, Zook? And if there's a list and I wanted them all, then I'll just have to, select them all, right? So wearables, it would be Fitbit API, Apple Health API, wherever the source data is. That could be SQLite local. And I'm basically saying, when does the data start? January the 1st. Do you want compute controls? Yes. Do you want to automate it? No. This is sort of repetition. So this should be hard words, the defaults, but you're just repeating the process. And then you join the experiment. So this time, if we go back to our personal list, you will see that this unique hash for my implementation of this reference, network experiment reference. So you'll see it's different from so this is generic one, D whatever. Whereas my implementation of it, right? So your implementation of it will have a different one, but we all know it references the same Genesis contract if you look in the code. And then we want to chart it out, so we click on the view button. So this is where it starts to hit SafeFlow, but as you can see, SafeFlow has no idea because there's no devices associated, so it's not giving you anything back. So it should really fail here and say, sorry, no data available. But once your data is there, then it would basically follow the instructions and produce a chart.
Well, interesting. So what kind of logic are you facilitating to one of our known blockchain to?
This is all the contribution stuff. But down here, I joined the network experiment. It all happened. It actually gone to PeerLink, gone to the library composer with all the tables, created the hashes, made the entry in the database, and then gave me back the hash. So there's a lot of stuff happening in those processes. The last one here is this out message. And this is what goes to SafeFlow. So it's the action, it's what the routing instruction is a network experiment. But then you've got the data. So you've got the hash of the holder of the whole experiment. Maybe go into that and you'll get the details of that, computational modules. So here's the modules. So that's the question, the data source, the compute, and the visualization. I've got the breakout here of all the details. If you go into information, you've got the controls. So it's saying yes, there's controls. This is the date I've asked for. Now this should also have the settings, x-axis. That's the data type hash for timestamp. And then we asked for car parking, so that's the hash for that column. So basically, it's giving you this bundle of modules and the reference contracts. And then over in SafeFlow, so here's the Genesis contracts being all routed through. But here you've got an input, a start. So again, the network experiment. And then here's the modules we just shown. Exactly the same hashes. And basically, SafeFlow is reading the information in all these modules and then all the reference contracts and then going through a logic. Which device are we talking about? Okay, it's this device with this data type on this date time period. It then goes to source. It says, is the results for that combination in memory? No. Is it in peer-to-peer, i.e. it's being processed and it's in the local peer data store in the right format? Yes, give it back. No, it's never been used before, so I have to go and call the REST API. Does the REST API data need to be tidy? Yes, go and tidy it. Does it need to be categorized? No, just skip it, then give it the information back. Does it need to be computed? Yes. What is it? An observation? Okay, just multiply by 1, give it back. Okay, what's the visualization? The visualization for charts.js. Okay, the data type now needs to be split into 2 types. The x-axis needs to be called labels, and the actual information of the chart called parking needs to be put into a data type structure for that. What color does the chart need to be, and data type, labels, etc. Okay, done all that there. Yes, it's now complete, sending a message back to the UI. The UI then takes that bundle of information and then does the processing to create a space on this canvas here to visualize it.
The hash is digital twin security, right? So it's kind of like a digital representation of a physical device.
Now, I don't want to go into this in too much detail. The simple version of what's happening in SafeFlow. As I went through all these major stages, I'm taking a hash print of the inputs and outputs. So there's like 6 or 8 of those. And once they're all complete, I do a hash of that. And that forms one half of the ledger entry in the knowledge bundle ledger. So that's the primary index. The proof of, has to complete. And the other hash is the actual output, the result format. The result format pre-visualization. So I could actually hash the visualization